Hello everyone, welcome to another Delphin video. Today we are going to continue our discussion of motion in a straight line, but we are going to look at one of the most common problems that a lot of students face when it comes to numericals and in general when it comes to kinematics. And it is when any object is falling from, or it is when any object is falling from any particular height, or we have thrown an object vertically and then it comes back, right? So how do we make those calculations related to those kind of problems? Something to note over here is that over here the motion does happen in unidimensional direction, but it happens along the y-axis, right? Previously we discussed examples where it is to happen, for example, you have a car, that's a weird car, but car moves just along the x-axis. Over here, we're going to look at when an object moves just along the y-axis. So, but before we dive right into it, I have two concepts that I wanted to introduce to you. First is, just understanding basic terminologies of what means when we say that an object is accelerating, or when we say that an object is decelerating when it comes to physics. So let's first clarify those concepts. I'm going to rub this. I just thought that I'll write the initial given values over there, but that's fine. So let's say there is a scenario where, so this is our frame of reference, okay, and this is our origin, so that is 0, and then you have x and y. This will be positive, this will be negative, this will be positive, this will be negative, right? So let's say an object is moving in this direction, right, along the x-axis, and while the object is moving, it is also accelerate. There is also acceleration. That is, its velocity is also changing in the same direction. So is accelerating in this direction, and at the same time velocity is also changing, right? When the velocity and acceleration happen in the same direction, we say that an object is accelerating, right? So an accelerating object is when the velocity, so the direction of velocity and the direction of acceleration are the same, right? So are both in the same direction. So let's say if it's in the positive x direction, the acceleration is on the positive x direction. When the object is moving in the negative direction, let's say its velocity is decreasing, it's moving in the negative direction, but its velocity is also decreasing with time, right? So its acceleration is also negative. So in that kind of scenario as well, we say that an object is accelerating, right? It's just that their direction is negative. So what matters over here is that the direction of velocity and acceleration should be the same, right? Only then can we call that an object is accelerating, and we call and something opposite to that is what we call as decelerating object, which is when the velocity and acceleration. So let's say the velocity is positive but acceleration is negative, the velocity is negative but the acceleration is positive, right? So so this is when we call it to be deceleration, right? Decelerating body, right? This is when we call that an object is decelerating. All right, so I just wanted to give you that brief context so that whenever you come across, so for one example over here would be, let's say, and we'll see an example of deceleration in this example itself. So yeah, so I'll give you an example over there, but I just wanted you to keep this concept in mind. It's not that important, like we're not gonna, but it's something interesting, right? So hopefully you found that interesting when it comes to physics. All right, so let's get back to the question. So a ball is thrown vertically upwards with a velocity of 20 meters per second from a top-story building, multi-story building. The height of the point from where the ball is thrown is 25 meters from the ground, meaning the height of the building is 25 meters, right? So you have 25 meters height of, and let's say there's a person standing over here. He's throwing the ball from that particular height. Question A is, how high will the ball rise? And how long will it be before the ball hits the ground, right? So there are two questions that we need to tackle. So this is what I'm going to do. I'm just going to rub this off and I'm going to start typing over here itself so that I can refer the diagram for you guys. All right, so Now let's look at, and they've given us g, which is 10 meters per second. So gravity is of course acting in this direction, so you have gravity is equal to 10 meters per second square. Now when it comes to reference, you can see that the acceleration is kind of in the negative y direction, right? So gravity is normally denoted as negative 10 meters per second square, right? So there are two scenarios over here to consider. First, when the ball is going upwards, and second, when the ball starts moving downwards, correct? So when the ball is moving upwards, we have given it a velocity, right? So it's moving, the change in position is happening in the positive y direction, right? So you have previously ball was over here, then it starts moving in this direction, so it is moving along the positive direction. So when you do like a change in position, the x2 minus x1 would be positive, right? So the velocity is positive, but the acceleration is constantly acting in the negative direction. So it's trying to reduce the speed of the object. I'm going to draw the acceleration by a negative red line, right? So the acceleration is happening in this direction, but the velocity is in this direction. So constantly gravity is trying to reduce the speed of the object, right? So there will be a point when the velocity becomes zero, right? So that would be when the object is at its maximum height. So we have one information that we can infer just by the kind of motion that we have in place. So at the topmost point, we know that the velocity is going to be zero. They have given us the initial velocity already. So we have u is equal to 20 meters per second. The v is equal to 0, right? So if this is the starting point, our final velocity, we're going to consider it to be 0 because we have to identify how high will the ball rise. And then we already know the acceleration is 10 meters per second square, right? So we are going to use equation that we have already previously derived, which is v square minus u square is equal to 2 delta x, right? So v square minus u square is equal to 2a delta x. Delta x is nothing but the s or x that we used to consider before, right? It's the same thing, or it is the change in the position of an object, right? So v square is 0 minus 20, sorry, was it 20? Yes, 20 square equal to 2 times acceleration is negative 10 minus 10 delta x, right? We're gonna just, this is equal to minus 20 delta x, and over here minus 20 square. We're gonna just cancel these negatives out. We have 20 cancels this one out. You have delta x is equal to 20 meters, of course, right? So now we have another value. We know how long, like how much the object is going to move, or how high is it going to reach from this particular point to this particular point. So this is again, okay, so since we have found this variable out, we're going to change the color to 20 meters. So we now know that the ball is at total height of 25 plus 20. So this total height is going to be 45 meters, correct? All right, so we have another information. Now the second question is, how long will it be before the ball hits the ground? So we need to find how long it will take for the ball to reach the ground over here, right? So let us start with first calculating how long will it take for the ball to reach from this point to this point, and then we'll calculate how long it will take for ball to reach from this point to this point. Does that make sense? So if this is A, B, and then you have C. So how long will it take to go from A to B and then from B to C? All right. So we're going to calculate the time it takes, time taken from A to B, right? So we're going to calculate that. In order to calculate that, what we need is, we're going to use a very simple formula again, which we already derived. V is equal to U plus AT, correct? We already know what is V. V is 0 when it goes from A to B. U is minus 20, no, sorry, it's 20 plus negative 10 times T, correct? We're going to take this over here. Time is equal to 20 by 10, that is equal to 2 seconds, right? So the time it takes from going from A to B is equal to 2 seconds. All right, so we have that one value calculated. Now we need to calculate the time taken from B to C. All right, so we want to calculate the time taken from B to C. All right, so what values do we have over here? So we know the initial velocity at that height, at that particular height, u, is going to be 0, which is nothing but our final velocity in the previous case, right? So it's going to start at a particular height with velocity v is equal to u is equal to 0, and then from it's going to drop to 45 meters, right? It is going to drop by 45 meters, and it is going to come at a constant acceleration of g is equal to minus 10 meters per second square, correct? So we know the initial velocity, we know the distance it's going to travel, and we know the acceleration, right? So what are the equations that kind of help us with that? Sorry, what is the equation that helps us with that? Initial velocity, we have the acceleration, and we have the distance it's going to travel, right? We have those three equations, those three values, and this is the perfect equation in order to solve that, correct? So let's use that equation. Delta x is equal to ut plus half at square. You have delta x is 45 meters, and you have u is equal to 0. Well, so you have 0 times t is 0. I'm going to 0 times t is equal to 0 plus half minus 10 times t square, correct? So you're going to take this over here. You have 90 square well, hold on. All right, sorry, this would be negative. All right, I apologize, that's what I was confused about. All right, this would be negative, sorry, delta, and to make it simple, it is delta y because it's moving in the y direction. So initially there is a particular y of 45, and then we are going to 0, so the delta would be 0 minus 45 meters, so it would be 45, negative 45 meters. That the change would be negative 45 meters. Sorry about that. So this negatives would cancel out. You get t square is equal to root of 9, and t is equal to 3 seconds. All right, so sorry about that confusion, but the time taken from B to C is equal to 3 seconds. All right, so the total time would be nothing but is equal to 3 plus 2 seconds, or sorry, A to B plus B to C, which is 2 plus 3 seconds, which is equal to 5 seconds, right? So the total time taken for the ball to go from A to B and from B to C is 5 seconds. All right, now let's look at a scenario. All right, so just to tie it all back up to these initial terminologies that we looked at. When the ball was going upwards, the acceleration was in the negative direction, correct? So velocity was in this direction, but acceleration was in the opposite direction. So in this case, we say that the object is decelerating, right? Because constantly its velocity is decreasing. Whereas when the ball was falling downwards, the velocity was in this direction, which was negative, because velocity, like when it changes from a positive y to a lesser positive y, it's going to be negative, right? But the acceleration was also in the same direction, correct? So this case, when both velocity and acceleration are negative, we say that this is an accelerating body, right? Even though both of them are in the negative direction, correct? So there's a misunderstanding when people say that, in general terms, when we say that when we think that when an acceleration is negative, we say that it's a decelerating body, but that's not the case, right? In order to say that a body is decelerating or accelerating, you have to take both velocity and the direction of velocity and the direction of acceleration into consideration. it just is not simple as saying that if an acceleration is negative, we say that that a body is decelerating, right? That's not what it means, right? Especially not in physics. All right. So I hope that helped you solve or get more insights into motion in a straight line. Further moving forward, we'll be looking at motion in a plane, where we'll discuss a special case where the object moves. It's a projectile motion, so it changes both its x and y axis at the same time. All right, so we're going to look at that. We're going to dive into vectors and all of that, so it's going to be fun. I hope you stick around. See you later.